Chapter 9, Sampling Distributions. Here's a diagram of a parameter versus a statistic. 9.1, Formulas and Examples. A parameter versus a statistic. So a parameter is a number that describes the population, whereas a statistic is a number that describes the sample. And sampling variability is the value of a statistic in repeated random sampling, where sampling distribution is values taken by the statistic in all possible samples of the same size from the population. Bias and variability. Variability of the statistic is determined by the size of the sample or experiment group. The larger the sample is, the less variability there is, because the sample would more closely assimilate the population. Bias is when the responses are different than the estimated population responses, so the results are far from the mean. So in this diagram, it shows the bias is large here, but the variation is small because all the data points are clustered in the same spot, making the bias large because it's not equally spread out, and the variation is small because they're all close together. Where in this diagram, the bias is small because they're equally spread out around the mean, and the variation is large because they're not close together and they vary around the target. The bias over here is large, and the variation is large because the data points, even though they're off in one section of the target, are still not close together like they are in this one. And the bias is large because the bias is in this section of the target. It's not spread out equally throughout the target. Whereas in this one, the variance is small and the bias is small because they're close together but also equal around the mean.
Here are 9.2 formulas and examples. So 9.2 was about sample proportions. And below right here, you can see all the formulas to find the proportion of p hat, the mean of the p hat, and the standard deviation of the p hat. And just as a little side note is that the standard deviation decreases as n increases. And over here for the formula for p hat, x equals the number of successes and n equals the number of observations in the sample. And the rules of thumb, you just need to make sure that are followed to make sure that the distribution is normal, is that the population is greater than 10n. So population n must be large enough. And also a side note, the accuracy of normal approximation increases as n increases. And then also p hat is approximately normal if the number of successes, which is equals n times p, is greater than or equal to 10, as well as the number of failures. So n times 1 minus p is greater than or equal to 10. So 9.2 continue, just some basic facts to remember while going through this chapter. When we want information about the population proportion p, we can take an SRS and use a sample proportion, p hat, which is what the formulas were all about last slide, to estimate the unknown parameter p. Sampling distribution of p hat describes how the statistic varies in all possible samples from that population. And then the mean of all p hats is p, and p hat is an unbiased estimator of p. So here's an example. So according to government data, 22% of American children under the age of 6 live in households with incomes less than the official poverty level. A study of learning in early childhood chooses an SRS of 300 children. What is the probability that more than 20% of the sample are from poverty households? So right here it says to remember to check that you can use the normal approximation. So that right here is done. Or the work is shown right here. So we check that the population is greater than or equal to 10n, which it is, it's 3,000. And then that NP is greater than or equal to 10, which it is 66. And then lastly, we check that n times 1 minus p is greater than or equal to 10, which it is because it is 234. And then up here, the problem doesn't tell you to do this, but you need to do it in order to solve it. So using the formulas from 2 slides ago, we find that the mean is 0.22, and then the standard deviation is 0.0239, and that is used right here on the the distribution as mu equals 0.22, and then the standard deviation is right here. And then right here it's small, but you see is 0.2. So this represents that we're trying to find the probability that is more than 20%. So then we do normal CDF with 0.2 to infinity being the range, 0.22 being the mean, and then 0.0239 being the standard deviation. And then we get the answer of 0.7987. So that is the probability that more than 20% of the sample are from poverty households.